Hi, I'm Sean Gann, and this is Minute Math, and today we're learning about derivative at a value.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals x squared plus 4x at x equals negative 5, and that is where we defined the derivative. Well, first things first is I need to find the derivative. So if this is my f of x, let's say, we'll call it f prime of x, to take derivative, well, we go through each part. Use the power rule here. X squared becomes a 2x, and then derivative of 4x is just a 4. Not too bad. Now we want to find the derivative at the value of negative 5. So we plug negative 5 in for x here of our derivative. F prime of negative 5 is equal to 2 times the negative 5 plus 4. And that comes out to be, a negative 6 when we simplify it. So we can write this answer as our dy dx of x equals a negative 5, and that equals a negative 6, and that is our final answer. We're given this problem right here, y equals a negative x to the third power plus 4x squared minus 4, and we need to find the derivative of that at x equals 4. Well, first thing I want to do is, find the derivative. So let's call this f of x, and we want to find f prime of x. So what is it equal to? Well, using our power rule, negative 3 comes down, negative 3x squared. Then we remember subtract the exponent to be a square, plus 2 comes down to multiply by the 4, 2 times 4 is at 8, x, subtract the exponent by 1, and then derivative of negative 4 is 0. So we have our derivative pretty easy to get right here, so let's go find what happens at x equals 4. So f prime of 4 is equal to negative 3 times 4 squared plus 8 times a 4. When we plug that in, we get, this comes out to be a negative 48 plus a 32 here, and that equals a negative 16. Well, we can write this now as a final statement of our dy dx of, or when x is equal to 4, is equal to a negative 16, and that is our final answer. We're given this problem right here, y equals 20 over x squared plus 5, and we need to find the derivative of that at x equals 3. Well, one thing I like to do is rewrite this problem, this equation, y equals, and I'm going to write it like this, 20 times our x squared plus 5 to the negative 1 power. That's really just a preference of mine, because when I take the derivative, I just like using the product rule, especially for something like this. So using the product rule, we have, I'll call it f prime of x, is equal to, derivative of the first value, the 20, which is a 0, times the second, x squared plus 5 to the negative 1 power, plus 20 times the derivative of the second part here, not power, which we're going to use the chain rule. Negative 1 comes out front, we have an x squared plus 5 right there, and the negative 1 power becomes a negative 2 by subtracting by 1. Inside, derivative of the inside using the chain rule, we just have a 2x as a derivative there. Well, luckily for us, this simplifies pretty easily. The 0 causes all that to be canceled out, not too bad. And negative 1 and a 2 and a 20 becomes a negative 40. And the numerator, and the x value, negative 40x, all over our x squared plus 5 in the denominator, and don't forget to square it. Okay? Making sure I'm on the right path, and we're good. So now, with our derivative here, we can find what happens at x equals 3. So let's find what f prime of 3 is by plugging that in. For x, we have a negative 40 times a 3 over 3 squared plus 5 all squared. This comes out to be, and hopefully you know how to do this stuff here, simplifies to be a negative 30 over a 49. So if we want to write this as a final statement, we would say our dy dx of, or when x is equal to 3 is equal to negative 30 over 49, and that is our final answer. We're given this problem right here, y equals 2 divided by x plus 1, and we need to find the derivative here at x equals 5. Well, I like to rewrite this function here, f of x, let's call it f of x, And I'll write it like this, 2 times an x plus 1 to the negative 1 power. That's mainly because I just like using the product rule better. It's personal preference, but you can use quotient rule here as well to find the derivative. So using the product rule, f prime of x, we have the derivative of the first part, 2, which is 0, times the second, x plus 1 to the negative 1 power, plus the first part, 2, times the derivative of the second part. We use the chain rule here, or power rule and chain rule. Negative 1 comes out front. We have an x plus 1 on the inside, and negative 2 up top. Then the inside derivative is just 1. Not too bad. Let's simplify this out a little bit. F prime of x here, well, 0 times anything is 0, kind of cancels out. Our numerator is 2 times negative 1 times 1, which is a negative 2, all over our denominator, an x plus 1, and it's going to be squared instead of a negative 2 power. Alright, making sure I'm on the right track, and we're still good. Alright, now we define it at x equals 5, so we take our derivative, f prime of x, but we want to put 5 in for x here. And that's equal to negative 2 over a 5 plus 1 all squared. Okay? Well, now we simplify this, and then that comes simplified out to be negative 1 over 18. So we have negative 1 over 18 as our answer. We can write it like this, dy dx, when x is equal to 5, is equal to a negative 1 over 18, and that is our final answer. We're given this problem right here, y equals a negative x plus 4 all to the 1/2 power, and we need to find the derivative at x equals 0. Well, let's first find the derivative here. So I'm going to write it as f prime of x, because I like writing it that way. And we're going to use, well, the power rule and chain rule here. 1/2 comes out front, keep the inside, negative x plus 4, subtract the exponent by 1, we have a negative 1/2 here. Multiply that by the derivative of the inside, which is just a negative 1. Now from here we can simplify this a little bit. F prime of x is equal to, we can write this as a fraction. The only thing in the numerator is that negative 1, so we have a negative out front, 1 up top. 2 stays down here, and then bring this 1/2 down to the denominator. That's right as a square root, and negative x plus 4. And it's pretty easy, we have our derivative. Now we want to find the derivative at x equals 0, so we take f prime of x and put 0 in for x. Same thing, we simplify or solve now. 1, 2, square root 0 in for x plus 4. Not too bad. This comes out to be, when it's all said and done, a negative 1/4. So we can write this now as a derivative, a dy, or final statement here, dy dx, when x is equal to 0, and that is equal to a negative 1/4, and that is our final answer. We're given this problem right here, y equals a negative 3x plus 9, all to the 1/2 power, and we need to find the derivative at x equals a negative 5. Well, let's first go find the derivative of the function in general. F prime of x, using the power rule here first, 1/2 comes out front, keep the inside the same, negative 3x plus 9, subtract the exponent by 1, negative 1/2. Multiply that by the derivative of the inside, which is just a negative 3. Not too bad. Now let's simplify this. F prime of x is equal to, across the numerator we have just a negative up front and then 3 up top. Denominator has this 1/2 right here, and the negative 1/2 power brings it to the denominator to the positive 1/2 power, which is the same as the square root. Square root of negative 3x plus 9. Making sure I have it good, and we're good. Alright, so now with this, we need to find it at x equals negative 5. So let's plug negative 5 in for x. F prime of negative 5 is equal to a negative 3 over a 2 square root of negative 3 times a negative 5 plus 9. This comes out to be negative 3 over 2 square root of 24, which if you practice your square roots, hopefully you know how to do it all and everything, simplifies to be a negative square root of 6 over 8. Alright, and so we can write our final answer here in this form, dy dx, when x is equal to a negative 5 is equal to a negative square root of 6 over 8. And that is our final answer. We're given this problem right here, y equals e to the negative x plus 2 power, and we need to find the derivative at x equals 4. Well, let's first go find the derivative of our function. Let's call it f prime of x here. And we have e to the u power, which is a derivative of u prime e to the u. So the derivative of the exponent is just a negative 1, and that's multiplied by e to our exponent, negative x plus 2. Pretty easy assuming rule here. Simplify that, we have f prime of x is equal to just a negative e to the negative x plus 2 power. Alright, not too bad. Well, we want to find it at x equals 4. So let's plug 4 into our derivative, f prime of 4 here, and that's equal to a negative e to a negative, then 4 plus 2 power. Okay? This simplifies to be a negative 1 over e squared. Remember, negative 4 plus 2 is a negative 2, and we can bring that down to the denominator. So we can write it in terms of e of negative 1 over e squared. So how can we write this in our final statement? dy dx, when x is equal to 4 here, is equal to a negative 1 over e squared, and that is our final answer. We're given this problem right here, y equals the negative natural log of x plus 3, and we need to find the derivative at x equals 5. Well, our rules for the derivative natural log, the natural log of u is equal to 1 over u times u prime. So let's go find the derivative here, f prime of x here. Negative can really just stay out front. And we have 1 over u being the inside. So 1 over an x plus 3 times the derivative of the inside. And the derivative of x plus 3 is just 1. Simplify this out a little bit. F prime of x is equal to just, well, negative 1 over x plus 3. Don't need that inside there. Well, we have to find the derivative at x equals 5. So we find f prime of 5, and we plug 5 in for x. Pretty easy. Negative 1 over 5 plus 3, which is equal to negative 1 over 8. So we can write our final statement here to show it, dy dx, when x is equal to 5 is equal to negative 1 over 8. And that is our final answer. We're given this problem right here, y equals 2 times the sine of 2x, and we need to find the derivative of that at x equals a negative pi over 2. Well, first let's go find the derivative of our function. F prime of x is equal to, well, the 2, the constant kind of can just stay out there, don't really worry about that. But then we're multiplying that by the derivative of the inside, derivative of 2x, which is a 2, times derivative, and then this becomes cosine of the inside, which is 2x. Because remember, when we had derivative of sine of u is u prime cosine of u. Simplify this out slightly, we have f prime of x is equal to 4 cosine of 2x. So now we have our derivative. Let's go plug in our value at negative 1 pi over 2. So we have f prime of negative pi over 2, and make sure you plug it into f prime, guys. 4 cosine of 2 times our x value, negative pi over 2. And now let's simplify this, okay? Well, we have f prime of negative pi over 2 is equal to 4 cosine, 2's cancel out, of negative pi. Cosine of negative pi is a negative 1, so we have 4 times a negative 1, and we have a negative 4 overall. So we can write our answer like such, dy dx, where x is equal to a negative pi over 2 is equal to a negative 4, and that is our final answer. We're given this problem right here, y equals a negative tangent of 2x, and we need to find the derivative there at x equals a negative pi. Well, let's go find the derivative first. What is f prime of x here, or y prime? Well, the negative is put up front, and the derivative of tangent, all right, tangent of u is u prime secant squared of u. So derivative of the inside of 2x is just a 2, times the secant squared of the inside, 2x. Simplify this out slightly here, and we really just have an f prime of x, getting rid of our parentheses here, as a negative 2 secant squared of 2x. So right now we need to plug in a negative pi in for x and solve of our f prime of x. So f prime of negative pi is equal to a negative 2 secant squared of 2 times a negative pi. Well, rewrite that out. F prime of negative pi is equal to negative 2 secant squared of a negative 2 pi. Okay? And the secant squared of negative 2 pi comes out to be just a 1. And negative 2 times 1 is a negative 2. So we can write this final answer here in the form of dy dx when x is equal to a negative pi is equal to a negative 2, and that is our final answer. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.